Conduction. Most of us enjoy roasting marshmallows over a campfire. If you hold the marshmallow with a metal fork while waiting for it to develop a crunchy surface, the fork may become too hot to hold. Heat enters the end of the fork that is kept in the flames and is transmitted along the entire length to your hand. The transmission of heat in this manner is called conduction. The fire causes the atoms at the heated end of the fork to vibrate more rapidly. These atoms vibrate against neighboring atoms, which, in turn, do the same. More important, free electrons that can drift throughout the metal are made to jostle and transfer energy by colliding with atoms and other free electrons within the material. How well a metal fork or any solid object conducts heat depends on the bonding within its atomic or molecular structure. Solids composed of atoms that have one or more loose outer electrons conduct heat and electricity well. Metals have the loosest outer electrons, which are free to carry energy by collisions throughout the metal. That is why metals are excellent conductors of heat and electricity. Silver is the best conductor, followed by copper and gold, and, among the common metals, aluminum, with iron well behind. Most liquids and gases are poor conductors. Poor conductors that impede the transfer of heat are called insulators. Wool, wood, straw, paper, cork, and styrofoam are good insulators of heat. Unlike the electrons in metals, the outer electrons in the atoms of these insulators are firmly attached. Because wood is a good insulator, poor conductor, of heat, it is used in the handles of cookware. Even when it is hot, you can grasp the wooden handle of a pot with your bare hand and quickly remove the pot from a hot stove without getting burned. Grasping an iron handle of the same temperature would surely burn your hand. Wood is a good insulator even when it is very hot, which is why firewalkers can walk barefoot on red-hot coals from firewood without burning their feet. Caution: don't try this on your own. Even experienced firewalkers sometimes receive bad burns when conditions aren't just right, bits of coal sticking to their feet, for example. The principal factor in firewalking is the low conductivity of wood, even red-hot wood. Although its temperature is high, relatively little heat is conducted to the feet, just as little heat is conducted by air when you put your hand briefly in a hot pizza oven. If you touch metal in the hot oven, ouch. Similarly, a firewalker who steps on a hot piece of metal or another good conductor will be burned. Evaporation of moisture on wet feet can play a role in firewalking too. Air is a very poor conductor, which, as we said, is why your hand isn't harmed if you put it briefly in a hot oven. The good insulating properties of materials such as wool, fur, and feathers are largely due to the air spaces they contain. Other porous substances such as fiberglass are likewise good insulators because of their many small air spaces. Be glad that air is a poor conductor. If it were not, you'd feel quite chilly on a 20 degrees Celsius, 68 degrees Fahrenheit, day. Dry wood. Hence, a blanket of snow can literally keep the ground warm in winter. Snowflakes are formed of crystals, which collect into feathery masses, imprisoning air and thereby interfering with the escape of heat from Earth's surface. Traditional Arctic winter dwellings are shielded from the cold by their snow covering. Animals in the forest find shelter from the cold in snowbanks and in holes in the snow. The snow doesn't provide warmth, it simply slows down the loss of the heat that the animals generate. Heat is transmitted from a higher to a lower temperature. We often hear people say that they wish to keep the cold out of their homes. A better way to state this is to say that they want to prevent the heat from escaping. There is no cold that flows into a warm home, unless a cold wind blows into it. Cold is simply the absence of heat. A home becomes colder because heat flows out. Homes are insulated with rock wool to prevent heat loss rather than to prevent cold from entering. It is important to note that no insulator can totally prevent heat loss. An insulator merely reduces the rate at which heat penetrates. Even the best insulated warm homes in winter will gradually cool. Insulation slows heat transfer. CHECKPOINT 1. In desert regions that are hot in the daytime and cold at nighttime, the walls of houses are often made of mud. Why is it important that the mud walls be thick? 2. Why can you place your hand briefly inside a hot oven without harm, but you are burned if you touch the metal sides of the oven?